Hello everyone, I am Dr. P.S.V.Shanmukhi, Associate Professor, Department of Physics, Aditya University. Now I am going to explain about the p-n junction diode. At the end of this lecture, student will able to understand the formation of p-n junction diode and also he can understand the VI characteristics of a p-n junction diode. Coming to a p-n junction diode, when a p-type and n-type semiconductors are joined metallurgically, then a p-type p-n junction diode is formed. So generally a p-type and n-type semiconductors are joined together, not mechanically, metallurgically they are joined together, say p-n junction diode is formed. So how a p-n junction diode is formed? Coming to that one, suppose when p-type semiconductor and n-type semiconductor they are joined together, what happens? Generally in case of p-type semiconductor, at any temperature other than 0 degree Kelvin or moderate temperatures, holes are the majority carriers and electrons are the minority carriers, and also there exists some acceptor impurities like boron, aluminum, like that. In the same way, in case of n-type semiconductor, there exists electrons are the majority carriers, holes are the minority carriers, and also there exists some donor impurities like the arsenic, phosphorus, etc. Whenever these two are joined together, what happens? Generally from n side more number of electrons are there, electrons concentration is more. From p side more concentration of holes is there, or holes are the majority carriers. Generally there exists a diffusion of the carriers. Electrons will be diffused into p region from n side, holes will be diffused into n region from p side. So holes are moving towards n side, and actually in case of p-type semiconductor there are some acceptor impurities also, they are actually immobile. So they are not moving, they will not move, that's why the holes are going into this region, electrons are going into the p side by leaving the positive donor impurities. Actually at the junction region there exist some recombinations, electrons and holes will be recombined, pair annihilations will take place. That's why at the junction region a charge free region will be developed there. Charge free region means, okay, negative acceptor ions and positive donor impurities, donor ions are also there, but charge carriers are not there, that's why that is called charge free region. So say this is a p-n junction diode, a depletion region or charge free region is developed here. This is a p-type semiconductor and this is n-type semiconductor. Say here the negative acceptor ions are accumulated, here the positive donor ions are accumulated. In between these two a voltage is developed there. This voltage is called barrier voltage or built-in voltage. This voltage, say V0, it opposes the further flow of the carriers. From p side, suppose still the holes are trying to diffuse into n region, they are repelled by the positive donor ions from n side. Similarly electrons they try to go into the p side, they are repelled by the negative acceptor ions. That's why these charge carriers cannot transfer, they cannot move from one place to another place. So this is actually called unbiased p-n junction diode. So this is an unbiased p-n junction diode, p side and n side. So in this way a p-n junction diode is formed. Generally when a p-type semiconductor and n-type semiconductors are joined together at the junction, the holes from p side, majority carriers, they will diffuse into n region, electrons from n side they will diffuse into p region. At the junction recombinations will take place, that's why charge free region is developed there. But actually from p side and n side there are some immobile acceptor and donor impurities or ions, that's why a voltage is developed there, that is called V0, junction voltage or barrier voltage. This is actually unbiased p-n junction diode. Suppose when it is biased, actually two types of biasings we will give. we call them as forward bias and reverse bias. So forward bias means when the positive terminal is connected to P side, negative terminal is connected to N side, we call it as a forward bias. Otherwise, if the negative terminal is connected to P side, positive terminal is connected to N side, we call it as reverse bias. So under forward bias and reverse bias, what happens? Under forward bias, suppose say a PN junction diode, this first one is denoted by reverse bias case and this is denoted by forward bias. Here let us observe N region is connected to negative terminal and P region is connected to positive terminal of the battery. Under this condition, what happens? The holes are pushed into positive terminal, holes are the majority carriers in P side and positive terminal, there is a repulsion between these two, holes will be pushed into N region now. Similarly, negative terminal and N region, there is a repulsion between negative terminal and electrons, that's why electrons will be pushed into P region. As a result, current flows under forward bias, but actually there is some opposition, junction opposition is there V0. For example, if this V0 is equal to 0.3, coming to when the forward voltage 0.1, 0.2, 0.3 etc. forward voltage is applied, up to a certain voltage no current flows. That means when you increase the forward voltage, the barrier voltage or the barrier width gradually decreases. At V is equal to V0, it vanishes. That's why suddenly huge current flows under forward bias. So we get a curve like this, and as we are increasing the forward voltage, the forward current IF is increasing. This is the forward current, IF is increasing, and up to a certain voltage it is not showing anything, almost zero. Afterwards a little bit it is increasing, suddenly it reaches to almost infinity. Extrapolating this one, it will cut the x-axis, it will show the barrier voltage or built-in voltage or cut-in voltage. This is called forward characteristic. Under forward bias we get like this. Coming to the reverse bias, reverse bias means when the positive terminal is connected to N side, negative terminal is connected to P side, it is called reverse bias. Under reverse bias, what happens? Actually, the N side, there are more number of electrons, majority carriers, they are attracted by positive terminal. This P side, more number of holes are there, they are attracted by the negative terminal. That's why the depletion layer width increases. As we are increasing the reverse voltage, so the depletion layer width is increasing, that's why the current should be zero. But actually there are some minority carriers also in N and P side. Holes are the minority carriers in case of N side, electrons are the minority carriers in P side. So when the reverse bias is applied, the minority carry electrons from N side, they will be pushed into the next region. The minority carriers holes, they will be pushed into the next region from P side. As a result, minority carrier current flows. That means when you connect this one, a milliammeter, so no current shows in the circuit. A microammeter is connected, say almost it shows some little bit current. That is due to minority carrier current, microamperes current flows. That's why when you observe the VI characteristics of this one, as we increase the reverse voltage, this is VR and the current IR is taken on the Y axis. As we are increasing 1, 2, 3, 4 etc. volts, up to a certain voltage very minute current flows. Suddenly at a certain voltage what happens? The current almost reaches to infinity. Why it is like that? As we are applying the reverse voltage, the barrier width is increasing. Up to a certain thing it happens. After a certain reverse voltage, high reverse voltage, so as there is no elastic property, the junction breaks. When the junction breaks, what happens? Suddenly huge current flows across the junction. That's why in the reverse bias also we can find current like this, that is in the reverse region. This is actually called as breakdown voltage. There are actually two types of breakdowns, namely Zener breakdown and avalanche breakdown. Zener breakdown occurs in case of Zener diodes, that what we discuss, and avalanche breakdown occurs in case of lightly doped PN junction diodes. Anyhow, this is the forward characteristic, VI characteristics, as we are increasing the forward voltage, the current is 0 up to a certain voltage and barrier voltage. Afterwards, the current increases a little bit, suddenly it goes to infinity. And afterwards, in the reverse bias, as we are increasing the reverse bias voltage, it is showing the reverse current or that leakage current due to the minority carriers. Afterwards, up to a certain voltage, it happens like that. Suddenly, the junction breaks. Therefore, infinite current flows across the junction. This is the VI characteristics of the PN junction diode. So, coming to the summary of this one, in this article what we have discussed is the formation of PN junction diode, how a PN junction diode is formed. So, when a p-type and n-type semiconductors are joined together metallurgically, a PN junction diode is formed. It is actually unbiased PN junction diode. So, we discussed also the VI characteristics of the PN junction diode. Under forward bias, how the current changes with voltage, and under reverse bias, how the current flows with the voltage. That what we have seen in this article. Okay. Thank you very much.